we will talk about operations of radicals. Before we do the addition, subtraction, multiplication, division of radicals, we need to review some simple facts. We know again, 1 squared is 1, so radical 1 then is 1. 2 squared is 4. Then using the right hand side, radical 4, then we have a 2 without square. 3 squared is 9. So from the right hand side, 9 goes to 3, so we put radical 9, radical over 9, and then we got 3. And here 4 squared is 16. So from 16 to find 4, then we need to put radical sign above 16, and then we write 4 there. We know 4 is 2 squared. So radical 4 equals 2 is actually radical 2 squared, which is 2. 9 is 3 squared. So radical 9 is actually radical 3 squared, which equals 3. Radical 16 is 4 because 16 is 4 squared. So radical 4 squared is actually 4. In general, we have a radical a squared is a, if a is greater than 0. That's one thing we need to remember. The second thing is that we know radical 36 is actually 36 is 4 times 9 because 4 times 9 is 36. But you know 36 whose radical is 6 because 6 squared is 36. Okay? So it's like 4 squared is 16, radical 16 is 4. Okay? We know 6 is 2 times 3, and 2 is radical 4. Okay? 2 is radical 4. And 3 is radical 9. Okay? 3 is radical 9. This tells us that radical 4 times 9 equals radical 4 times radical 9. Okay? In general, we have a radical a times b equals radical a times radical b. Similarly, one can have radical a divided by radical b equals radical a divided by radical b. Okay? The same thing. Note, from here radical a times b equals radical a times radical b. Now we have a radical a 2 times radical 2. Okay? So a, b are equal in this case. 2 equals 2. Radical 2 times radical 2 based on this rule equals radical 2 times 2 equals a times b, because a, b are equal in this case. We know 2 times 2 squared. 2 times 2 is 2 squared, and the radical 2 squared is 2. Okay? You see, radical 2 squared is 2. So, radical 2 times radical 2 is 2. Okay? Also, in general, you have a radical 3 times radical 3 is 3. You have a radical a times radical a is a if a is greater than 0. Now, the second note is that radical 3 squared plus radical 4 squared does not equal radical 3 squared plus radical 4 squared. You separate these only if it's multiplication. You cannot separate this when here is addition or subtraction. You see radical 3 squared, choose the radical 3 squared is 3, radical 4 squared is 4, 3 plus 4 is 7. Okay? But inside here, radical 3 squared is 9, 4 squared is 16. Radical inside 9 plus 16 is 25. You choose the radical right here on 25. You then have a radical 25 is 5. 5 does not equal 7. So that's why right here you cannot separate this plus, okay, or minus. That's the second note. The third note, we know when 4x plus 11x, you only need to add coefficient 4 plus 11 because they are 15. 4 plus 11 is 15, and then you need to put x behind it. You combine like terms. You don't add x. The reason is because distributive property, you see x times 4, you get 4x. X times 11, you get 11x. That's because of distributive property. Alright, with this thing in our mind, our first operation is do the addition. For 6 radical 7 plus 9 radical 7, then we know you only need to add is 6, 9, that's 15, and put radical 7 behind it. You don't need to add radical 7. The same reason right here. Radical 7 is like an x. Now try this one yourself. 9 radical 13 minus 4 radical 13. The final answer is 5 radical 13. Try this one yourself. Is 9 minus 4 is 5. Okay, that's easy one. This one looks harder. We have more steps. 9 radical 48 minus 5 radical 27 plus 3 radical 12. We want to add plus minus. We want to do something right here. You know, 48 factor tree is 2 times 24 is 48. 24 is 3 times 8. And 8 is 2 times 4. 4 is 2 times 2. Eventually, 48 can be written as 2 times 2 times 2 times 2 times 3. There are 4 2's right here. So it's 2 to the 4th times 3. 1, 2, 3, 4. 2 to the 4th times 3. Okay? And 9, you keep it. Similarly, you keep 5. Radical 27 is 3 cubed, because 3 times 3 times 3 is 27. And then 12 can be written as 3 times 2 squared. 2 squared is 4, 4 times 3 is 12. Okay? So that's the first step. We need to use the big factor tree to write all those numbers inside the radical sign, not outside of the radical sign. Now we know 2 to the 4th is 2 squared times 2 squared. Okay? And we keep 3 down here. 3 cubed can be separated as 3 squared times 3. And we keep 3 times 2 squared. We keep it. The reason I do this is because radical 2 squared is 2, you see? Radical 2 squared is 2. So this 2 can be out. So 9 times 2. The second also is radical 2 squared, so 2 can be out. The third one, 3 without squared, so 3 stay inside the radical sign. Now, 5 times radical 3 squared times 3. The first 3 with squared, so 3 can be out. The second 3 without squared, so the second 3 stays inside the radical sign. So you have a 5 times 3 minus here. And then 3 times this 2 with squared inside the radical, so this 2 can be out. This 3 without squared, so radical 3 stays inside radical sign. Okay. Now 9 times 2 times 2, which is 36. Keep radical 3. 3 times 5 is negative 15, because here there is a negative. You put negative 3, radical 3 behind it. 3 times 2 is 6. Keep radical 3. Now you have a 36 radical 3 minus 15 radical 3 plus 6 radical 3. You do is 36 minus 15, which gives us what? 21. 21 plus 6 will have 27. So 27 radical 3. Okay? This one looks a little bit complicated. So here is the other one you want to try yourself. Okay? So you want to rewrite 28. 28 is actually 2 squared times 7. Okay? And then that 2 can be out. So 3 times 2 is 6, radical 7. Here you have a minus radical 7, you can cancel each other. And then minus 2 radical 175. 175, you know, it can be written as 5 squared times 7. And radical 5 squared times 7, 5 can be out. So 2 times 5 is negative 10, because there is negative here, and the radical 7, you leave it. So try this one yourself. The second one, this one is a new example. You do radical 5 times radical 15 minus radical 27. So you do distribution, distributive property. Okay? Radical 5 times the number here, and radical 5 times the number right here. Radical 5 times radical 15. Radical 5 times radical 27. Distribution, distributive property. Now you know radical 15 can be written as 3 times 5. And radical 27, previously we have it, that's 9 times 3. 9 is 3 squared, so it's 3 squared times 3, which is 27 right here. Now, radical 3 times 5 can be separated as radical 3 times radical 5. You leave radical 5 at the front. And here radical 5, you keep it. And then you have a radical 3 squared times radical 3. 3 squared inside the radical, so 3 can be out. Okay? It's like 3 squared radical is 3. So this 3 can be out, the first one. The second one, the 3 does not have a square, so 3 stays inside the radical sign. So you have a radical 5 times 3 from here, and then times radical 3. Now, radical 5 times radical 3 times radical 5. We know radical 5 times radical 5, which is 5, and then leave radical 3 here. Why radical 5 times radical 5 is 5? You see, it's like radical 3 times radical 3 is 3, radical 2 times radical 2 is 2, the same reason. So here we have a radical 5 is 5, and then times radical 3. Now, here you have a 3, you want to put at the front, and then radical 5 times radical 3 is 3 times 5 inside the radical. It's based on this rule, you see. Okay. So then we have a 3 times 5 inside the radical is 15. We keep 3 down here. And we didn't do anything with 5 times radical 3. And this is the final answer. So do this one yourself. Again, radical 2 times radical 6. And then radical 2 times 3. So radical 2 times 3 is 3 radical 2. And here, radical 6 is radical 2 times radical 3. So this is the final answer. Think about it. Why? Do the things we did similarly right here. Try this one yourself. Final answer. Now, let's see how to rationalize denominators. You know, here, negative 10 divided by radical 5, 5 is inside radical sign. And then if both numerator and denominator multiplied by radical 5, we know radical 5 times radical 5 is 5. Again, it's because something right here. Radical 3 times radical 3 is 3. Radical A times radical A is A. The same reason. So when you see radical 5 here, you give another radical 5. And then radical 5 times radical 5 is 5. Upstairs you have a radical 5. 10, it was there, you keep it. Now 10 divided by 5, you have a 2. Keep negative signs. Radical 5 was there. So final answer is negative 2 radical 5. Because 10 divided by 5 is 2. Okay. Try this one yourself. Both numerator and denominator multiplied by radical 3. So you have a radical 3 upstairs. Downstairs you have a radical 3 times radical 3, which is 3. And 9 divided by 3 is 3. So negative 3 radical 3. Try this one yourself. Now here is radical inside is one number divided by another. By this rule, radical A over B equals radical A divided by radical B. So you have this one equals that. Now you know radical x to the 4th can be written as radical x squared times x squared, because x to the 4th equals x squared times x squared. Downstairs, 20 can be written as 4 times 5. 4 is 2 squared. Okay? Now, inside the radical is x squared times x squared. So you know, previously we know radical a squared is a. So here, the first x with squared, then x can be out. The second one with x with squared on x. So the second x can also be out. So you have x times x. Now, denominator, you have 2 with squared, so 2 can be out. 5 without squared, so 5 stays inside the radical sign. Now you need to rationalize denominator. Here there is a radical 5. Then as the things we did over there, both numerator and denominator multiplied by radical 5. We know radical 5 times radical 5 is just 5. Again, it's like radical 3 times radical 3 is 3. So here radical 5 times radical 5, we have a 5. Times 2, we got 10. Upstairs is x times x, so we have x squared. Radical 5, you leave it. Okay, this is the final answer. Try this one yourself. Okay, the same way as we did above. Now, this is the final answer. Now, let's look at a little bit complicated one here. Again, we separate numerator denominators. Radical 1 numerator divided by a denominator. That's radical this numerator divided by radical 3z. 3z was the denominator. Now, 4 can be written as 2 squared, and x cubed can be written as x squared times x. Y to the 4th can be written as y squared times y squared. The reason I do this is that, again, inside the radical something squared, and that thing 2 in this case can be out. 2 squared inside the radical, so 2 can be out. Again, the reason is as before. Okay, is as before. Like here, 2 squared radical is 2. So here radical 2 squared, then 2 is out. X squared, so the first x is out. This x without squared, so it stays in. Y squared, so first y is out. Another y squared, the second y is out. Downstairs radical 3z, we still put it over there. Now, this is radical 3z. We want to rationalize that. So both numerator denominator multiplied by radical 3z. We know radical 3z times radical 3z is just 3z without radical. And the upstairs, we have 2xy times y, so it's 2xy squared. Radical x times radical 3z is radical 3xz. Is like radical a times radical b is radical ab. We don't write more than 2 radical signs. We write it as a single radical sign. And here we don't want the denominator has radical sign. That's why we do that. Try this one yourself. Radical 64 a to the 4th times b to the 6th divided by 3ab to the 4th. This is the final answer. 8ab times radical 3a divided by 3. This is slightly different from the above. You have a downstairs and a to the 4th upstairs. So you can a can be cancelled. Upstairs is a cubed. B to the 6th upstairs and b to the 4th. So b to the 4th can be cancelled. Upstairs can only have a b squared left over. Okay? So you need to do some cancellation first, and then separate numerator with radical, denominator with radical. Do the similar things I did right here. This is the final answer. Now, let's look at the last example. The last example is radical 3 plus 6 radical 5 times radical 3 minus 4 radical 5, close bracket. We do this one by FOIL method, F-O-I-L, FOIL method. The first one is radical 3 times radical 3. That's the first product. The outer product is radical 3 times 4 radical 5. Radical 3 times 4 radical 5 with negative sign. Inner product is 6 times radical 5 times radical 3 inside inner product. 6 radical 5 radical 3. 6 radical 5 radical 3. The last product, negative, positive is negative. 6 radical 5 times 4 radical 5. 6 radical 5 times 4 radical 5. Last product. Now again, radical 3 times radical 3 is 3. And then 4, you keep it. Radical 3 times radical 5, 3 times 5 is 15 inside the radical. And then 6, you keep it outside. 3 times 5 is 15 inside the radical. We know radical 5 times radical 5 is 5. 5 times 4 is 20. 20 times 6 is 120. Now, 3 with negative 120 gives us negative 117. And then here 6 minus 4 is 2. You keep radical 15. And this is the final answer. Try this one yourself. One quantity times another. This is the final answer. 59 minus 20 radical 6. Okay? So I will see you next time.